Hello everyone, I welcome you all to the second video in the Spring Core lecture series. In the previous video, we learned about the history of Java web development, evolution of Java Beans and Enterprise Java Beans specification, particularly the problems developers were facing at that time and solutions to those problems in the form of Spring Framework. This answered a very important question for us: why is there a need for Spring Framework? In this video, we will continue our journey on understanding Spring Framework. We will learn two important concepts, which are number 1, dependency injection and inversion of control. Number 2, beans in detail with the help of an example of dependency graph. These are the basic concepts governing Spring Framework, and understanding these will greatly help you understand Spring Framework. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. So what is dependency injection and inversion of control? To understand this concept, let me take the previous example of the communicator class. This example we have seen in the last video. Here it is represented as a interface. For clarification, when I say class, I mean its corresponding APIs exposed via an interface and its default implementation. The sole responsibility of this class is to communicate with users our various communication channels, namely email, SMS, WhatsApp, and voice call. One of the communication channels this bean communicates with user is via email. Now we have two options. Number 1, either to write the email sending part in the communicator bean itself, or number 2, to separate out the email sending part in a separate bean, as is shown here in option 2 with the help of email sender bean. Most certainly, it makes sense to go with the second option. Why? Simply because it modularizes the code further and designates specific roles and responsibility to each module. As a reference, I am showing you a simple implementation of an email sender bean. This bean integrates with various email providers to send email. Now, as we can see, the communicator bean needs access to the email sender object. In computer science terms, we call this a dependency. Communicator bean depends on email sender bean. How do communicator class gets access to this email sender object? One simple and trivial option is to instantiate it in the communicator constructor like this. But should we do it? In a real world production application, of course not. Why? Among many reasons, one is now communicator is not independently testable. In a testing scenario, we definitely wouldn't want to send out bogus emails to anyone, and ideally, we would like to mock out the functionality of email sender bean. This testing becomes more challenging if email sender bean depends on some other beans. For example, let's say C. Now take a pause and think, if not instantiating it ourselves, what other options do we have? Imagine a situation where some external system is responsible for instantiating the email sender object and setting that object to the email sender property in the communicator class. Wouldn't that be ideal? I would say yes, that would be ideal. The external system I'm talking about is the Spring Framework. This is what is known as dependency injection. Dependency injection is the process by which an object receives other objects it is dependent on via external systems. This pattern ensures that an object which wants to use a given object should not have to know how to construct those objects. As in this case, the communicator class should not have to know how to construct the email sender object. It is the responsibility of Spring Framework to construct the email sender object and inject that object. After dependencies are externally injected by the injector, the end result we are left with is known as inversion of control. Now one would ask which part of control is being inverted, and the answer is it is the acquisition of dependent objects which is being inverted. Applying IOC, objects are given their dependencies at creation time by some external system that coordinates each object in the application. IOC means an inversion of responsibility with regard to how an object obtains references to collaborating objects. Moving on, let us focus on dependency graph. If we recall, Java beans are Java classes which adhere to these following standard set of rules to be a valid Java bean. If a class does not follow these rules, they won't be a valid Java bean in the Java beans world. This is an example of a valid Java bean. It fulfills all three conditions. Beans in the Spring world have no such restrictions, and any Pojo class can be conceptualized as a bean. For example, consider this simple bean. It does not have a public no argument constructor and still is a valid Spring bean. The dependency expected as a constructor argument will be resolved by Spring framework. One more example of a valid Spring bean is this. This bean does have a public constructor, however, it expects its dependencies as setter arguments. Spring has no restrictions on bean declarations and it provides us with multiple options of declaring and using beans, which we are going to learn later on in this series. As we all know, beans encapsulates part of the functionality of an application, modularizes the code, and behaves as a reusable component. But beans don't work independently. It is highly unlikely for a bean to act independently. If we take our previous example of communicator, we see that communicator has a dependency on email sender bean. It is possible and even encouraged for email sender bean to internally depend on other beans to fulfill its responsibility. This example shows that email sender bean is dependent on three other beans. I understand some of the terms like mailgun, sendgrid, and SMTP are fairly new. However, no need to panic about them. For now, let us assume that these are different ways of sending email. Since these are different ways of sending emails, logically, we would want to separate them out in their own reusable components. As you can imagine, as application will grow larger, this will become more tedious. Representing these small dependencies visually would look something like this. For simple and small application, it is easy to represent dependencies and determine instantiation order. But as applications gets bigger and more complex, it is not so trivial and it becomes tedious. As we can imagine, these interconnected dependencies form some kind of a directed graph. The graph, which represents the dependencies of several objects towards each other, is known as dependency graph. It is important to represent dependencies in such a graph because, number one, by applying topological sorting principles, it is easy to determine the instantiation order in which the beans should be instantiated. Number two, circular dependencies can be easily identified and handled properly. Spring throws an error if it is not able to properly resolve circular dependencies. As developers, we should not worry about this complex graphical representation as it is Spring's responsibility to construct, manage, and use this graph. We only define the dependent beans for a bean as private class properties. Spring will go through the class definitions and find out the dependent beans and construct the dependency graph as shown previously. This concludes the dependency graph section. That's it for today's video. Comment your doubts in the comment section and I will try to resolve them. Let us quickly recap. In today's video, we learned number 1, what is dependency injection and inversion of control. Number 2, how dependencies are internally represented. Particularly, we learned that dependencies are internally represented as a directed graph. This directed graph is known as dependency graph. With the strong foundation of basic concepts, it will be trivial for you to understand the Spring framework. From the next video onwards, we will start our journey on understanding Spring framework in detail, particularly the Spring core container, its modules, etc. Once again, thank you and keep learning. I will see you in the next one.